We just created a nice flat surface at the end. Now we're going to drill a center hole. So that we can use the live center to support the other end of the workpiece for the next step, the turning operation for the 0.9-inch diameter. We chuck this center drill into the tailstock to perform the center drilling operation, and we're going to drill halfway to the taper portion of the center drill, and this taper angle is equal to the angle of this live center, so that we can, if you didn't cut to this portion, the center hole will not have enough supporting surface to use the live center. So we are going to cut about halfway to the taper surface when we drill the center hole. We can use the hand wheel to back off the tool, and at certain positions the push bar inside the tailstock is going to push the tool out. The tool is coming out. Now we can wheel it, extend it a little further out so we can slide the live center back in. Now the next step, we need to rechuck the workpiece so that we have at least 2-inch outside the chuck. And the next step, we're going to create a cylindrical surface of 0.9 inches for 2-inch long. So we'll cut all the way here with a diameter of 0.9, and after that, well, on top of this 0.9-inch diameter cylindrical surface, we'll cut it further down to 0.8 to generate this portion of the surface. Finally, we're going to cut the groove. First, we need to change the tool to turning tool. Then we need to measure 2 inches so we know where to stop the operation. And we're going to use the hook ruler to find the 2-inch mark. And we're going to move the carriage to the left until we see the 2-inch mark on the ruler aligned with the end of the workpiece. Okay, right here. So right now the tool tip is 2 inches away from the other end of the workpiece. So we're going to engage the live center into the workpiece. Ensure that you have some pressure, build up some pressure at the live center, and lock the live center in position. Now we are going to make we're going to scribe a line on the workpiece at the 2-inch length. So right now the tool tip is 2 inches away from the other end of the workpiece. So we're going to engage the live center into the workpiece. ensure that you have some pressure, build up some pressure at the live center and lock the live center in position. Now, we're going to scribe a line on the workpiece at the 2-inch length. Okay. Now with the tool in position, we're going to set the dial to 0, and this 0 mark is going to align with the reference mark that fixed on the hand wheel. Right now we have 2 references to help us determine the length of the travel for the turning operation. One is a scribed line on the surface, workpiece surface. The other one is more accurate reference, which was set by the dial indicator. The dial. Now we need to set the feet and speed. The speed will maintain the same at 650, and the feed we want to start with a rough cutting feed, a little faster feed. We recommend 0.0084, somewhere close 0.008 inch per or 8,000 inch per revolution is the right number to start with. And the combination for this machine is AD7. So the only knob setting that need to be changed is on the lever on the right. For the finish card, it was in position F. Now we need to change it to position D. Now let's find the surface. Bring the tool along the cross direction, make it close to the workpiece. So this is about right on the surface of the workpiece. So we're going to set this dial for the cross slide to 0, so we have a reference point for the depth of the cut. Now from the we're going to move the hand wheel 50 thousandths forward. So reduce the diameter by 50 thousandths of an inch. We start with 1 inch. After the first cut, we are going to anticipate or expect a diameter of roughly 0.95 inches. Start the spindle, engage the power feed along the cross direction. On the longitudinal or axis direction. When it's getting close to the mark, stop it, then manually bring the tool to the line of 0. When we move back along the longitudinal direction, the tool, the back side of the tool is going to make some scratch on the machine surface. But since it's rough cutting, we don't worry about too much on the machine surface quality. So that's okay. You don't have to back up the cross slide for the rough cutting, because of that way we can eliminate the error due to the backlash. So you don't have to move back and forth, just maintain the cross slide in position while you back off the tool. That's very important in order to achieve accurate diameter measure. Okay, let's measure the So what I'm reading now is 0.945946. And starting from here, we know that we need to remove another 46,000 to get the desired diameter, and maybe we take another 30,000, so leave about 16,000 for the finish cut. So from here, right now the mark aligned with 50,000, so we're going to move into 80,000 this time. And we'll repeat the rough cutting. Obviously the surface is not very pretty because of the scratch we made on the way back, and also the cutting condition we're using is pretty now. We leave about 14,000.914. So at 14,000, so we're going to move another 14, goes to 94. Now we're going to reduce the feed 2.0025 AF7. We can start the final cut. Back off the tool along the longitudinal direction. We don't want to damage the surface anymore because that's the final cut. And we want to take the chips out. Be careful, the chips can be very sharp. have a very nice surface created with a diameter of 0.9 inches and okay, we got exact 0.9 inches